Namaskar. Today we will study resistant tuberculosis. So tuberculosis is caused by Mycobacterium tuberculosis, and the challenges with tuberculosis are this microorganism is slowly growing, and when killed it is also killed very slowly, develop resistance to any one single drug, and can be dormant even after phagocytosis. So these are the challenges, and when if you see the resistance to anti-tubercular drugs mainly occurs because of the non-adherence or non-compliance. Because what happens since these anti-tubercular drugs develop resistance, we need to give a combination of drugs. Where there are one thing is there is combination of drugs. Second thing, it is given for a long duration, and to avoid the non-adherence and non-compliance, there is DOTS program. What is DOTS? Directly observed therapy using short course. So for a duration of 6 to 9 months, the drug is to be given under direct observation, so that there will be no non-compliance or non-adherence to the drugs. So it has one initial intensive phase where 3 to 4 drugs are given: isoniazid, rifampin, pyrazinamide and ethambutol, for either 2 or 3 months, and it is followed by the continuation phase. Only 2 drugs, isoniazid and rifampin, are given. So if it is 6 months, then 2 months plus 4 months. If it is 9 months, it is 3 months plus 6 months. Even after that, there is resistance, and not resistance not to a single drug, but to multiple drugs. And there are two types of resistant tuberculosis. We can say MDR TB, that is multidrug-resistant tuberculosis, and XDR TB, extensive drug-resistant tuberculosis. So what is the mechanism of resistance? The first thing is the inability of the drug to permeate into the cell, the mycobacterial cell, which is having highly hydrophobic cell envelope. So decreased permeation is one mechanism. The second mechanism is the highly developed efflux system of mycobacteria, so that the drug is effluxed outside. So the drug cannot enter. This is first one. Second one, well developed efflux system, so that the drug is effluxed out from the mycobacterial cell. And the mycobacteria can also develop some drug modifying enzymes like beta-lactamases and aminoglycoside acetyltransferase. Beta-lactamase in case of beta-lactam antibiotics like amoxicillin. Then aminoglycoside antibiotics, aminoglycoside acetyltransferase enzyme is providing that resistance to aminoglycoside antibiotics. And then there can be mutation to certain genes. So the genes which are involved in tuberculosis for individual drugs, isoniazid, there is involvement of INHA, CATG, CAS-A, HPC, rifampin, there is RPOB gene, pyrazinamide, PNCA, RPSA gene, ethambutol, EMBB, EMBCAB gene, streptomycin, RPSL, RRS, GIDB gene. All these genes are involved in resistance. Okay. Quinolones, GYRA, because quinolones inhibit DNA guidage, GYRA, GYRB, PARC, PARE, these are the genes involved in quinolones and fluoroquinolones resistance, quinolones and fluoroquinolones. Then capreomycin, RRS and TLYA, kanamycin or amikacin, RRS, ethionamide, ETHA or ETAA, ETHR, INHA, the same gene that of isoniazid. para-aminosalicylic acid THYA and folic acid that is fol C gene, because para-aminosalicylic acid is a competitive inhibitor of PABA and inhibit folic acid synthesis. Then cycloserine, two genes ALRA and CYCA, clarithromycin EMR37, clofazimine MMPL5, linezolid RPLC, bedaquiline the new drug ATPE, delamanid the new drug RV3547, benzothiogenones the new drug DPRE1, DPRE2, RV3790. So all these genes are involved in resistance of all these drugs. So we have to these are the mechanism of resistance, and in this case of resistance we have to give some additional drugs to counter that, and how to deal with that. And if there is resistance to isoniazid, then what we can give? So initially what is there, the in the DOTS program we have the first line drugs and we have the second line drugs like fluoroquinolone, aminoglycoside, macrolide, cyclic peptide, oxazolidinones, all these drugs including the new anti-TB drugs. The first line drugs, the four essential drugs: isoniazid, rifampin, pyrazinamide and ethambutol. And when we give it, the initial phase contains 3 to 4 drugs: isoniazid, rifampin, then pyrazinamide, if required ethambutol. Then continuation phase, only isoniazid and rifampin, 2 drugs. So when there is resistance to isoniazid, we give a combination of 3 drugs for 6 to 9 months: rifampin, pyrazinamide and ethambutol for 6 to 9 months. If there is resistance to rifampin, then we give isoniazid, pyrazinamide and ethambutol, because these 4 are the first line essential drugs: isoniazid, rifampin, pyrazinamide and ethambutol. So if there is resistance to rifampin, we give isoniazid, pyrazinamide and ethambutol for 6 to 9 months. And when there is resistance to 2 drugs, so multi-drug resistance starts: isoniazid and pyrazinamide. It may include resistance to streptomycin or may not include also. So in that case we give the other 2 primary drugs, that is first line drugs, that is ethambutol and rifampin, plus 2 second line drugs, one from fluoroquinolones and other from aminoglycoside. So one fluoroquinolone and one aminoglycoside, that is most preferred is amikacin, again for 6 to 9 months. So we have to give 4 drugs now. Then if there is resistance to isoniazid and ethambutol plus minus streptomycin, then the other 2, rifampin and pyrazinamide plus fluoroquinolone and amikacin for 6 to 12 months in this case. And when there is resistance to isoniazid and rifampin, the 2 most useful drugs, the essential drugs in TB treatment, plus minus streptomycin, then the duration has to be increased. So ethambutol and pyrazinamide, the other 2 first line drugs, plus 2 second line drugs, fluoroquinolone and amikacin, for 18 to 24 months, and surgery if required also has to be there. And when there is resistance to 3 drugs, so we are discussing the resistance to the first line drugs here. So isoniazid, rifampin and ethambutol, 3 first line drugs resistance is there. Then the other first line drug, that is pyrazinamide plus fluoroquinolone plus amikacin plus 2 other second line drugs from all these 2 other second line drugs, including this amoxicillin clavulanic acid or clarithromycin or linezolid. Okay, so again here the duration will be 24 months, and when it is converted to sputum, surgery has to be there. Surgery after sputum conversion has to be there. Similar is the case of isoniazid, rifampin and pyrazinamide plus minus streptomycin. So here the only first line drug remains is ethambutol. So ethambutol plus fluoroquinolone plus amikacin plus 2 more second line drugs. Again for 24 months or 2 years, and surgery after sputum conversion. And when there is resistance to 4 first-line drugs, all the first-line drugs are resistant, isoniazid, rifampin, pyrazidinamide and ethambutol plus minus streptomycin, then we have to give the fluoroquinolone, amikacin plus 3 second-line drugs. So total 5 second-line drugs will be there, and it will be for a duration of 24 months, and surgery if possible. If possible, then there will be surgery. Otherwise, the patient will die. So this is all about treatment of resistant tuberculosis, the MDR and XDR TB. Thank you.